Writing recursive rules for arithmetic and geometric sequences. Write a recursive formula for each sequence. Okay, so we have two sequences here. I'm going to start with the one on the left. Now, they don't specify whether these are arithmetic or geometric sequences. So first we need to figure that out. So I need to think about how I can get from 1 to 5. I see that I could either add 4 or I could multiply by 5. Now I'm going to see which one of those continues the pattern here. So to get from 5 to 25, I could add 20 or multiply by 5. So I see that I'm multiplying by 5 in each case here. Now if that's not obvious to you, here's a good way to check on your calculator. All you have to do is take the second term and subtract the first term. This is checking to see if it's arithmetic. There's 4. Then take the third term and subtract the second term. If these numbers are different like this, we know it cannot be arithmetic. So now we check to see if it's geometric. We take the second term and divide it by the first term. There's what we would multiply by. Then we take the third term and divide it by the second. If these numbers are the same, it's looking like it's going to be geometric. Now I'm going to check my last one here just to be sure. My last term divided by my third term. So because each of these are 5, I can tell that I'm multiplying by 5. I can be absolutely certain that I'm multiplying by 5 here every time. Okay? So I can tell it's a geometric sequence with my ratio, my common ratio being 5 because I'm multiplying by 5. Now, I'm going to rewrite this section here down here so I have some more room to write. A sub 1 means the first term in my sequence. I just look up here and see that 1 is the first term in my sequence. So that's all you have to put in this box, 1. Now in order to write my a sub n formula for my recursive formula, I know every time I'm doing a sub n, I know I have to have the previous term, which we write as a sub n minus 1. Then I know, so for example, to get the fourth term, if I was finding a sub 4, I'd be trying to find 125. So I would take the 25, the previous term, and I would multiply it by 5. And that's it. Any term equals the term value of the last term times 5. And we can keep going forever, on and on and on. Now just a quick note about how to plug this into ALEKS. In this box here, there's a button over to the side that looks like this. It has two little boxes. You want to click on this button and then plug in A here, and you'll have to type n minus 1 in the little box. Then make sure when you do your multiplication or addition that goes big again, that it's not stuck down there in the little box. So that's how you type it in, by clicking that button that has two squares on it. So this is all you do for the first one. For the second one, I again need to find whether it's arithmetic or geometric. So I could get from 9 to 5 by subtracting 4. I can get from 5 to 1 by subtracting 4. And I can get from 1 to negative 3 by subtracting 4. So that's looking pretty good to me that it's going to be arithmetic. Again, if that's not obvious to you, the way you can check is take the second term, 5, minus the first term, 9. That would be your common difference. Take the third term, 1, and subtract the second term, which is 5. Because these two numbers are the same, that bodes well for us. So then we do negative 3 minus 1, and there's our common difference. And because we were subtracting here, it's arithmetic. All right, so I know that my common difference is negative 4. Now I'm going to rewrite this down here again. So I have a sub 1 equals, that's just the first term in my sequence, so that's 9. Now I have a sub n. And just like I did on the one before, I'm going to click that button with the two squares, and I'm going to do a sub n minus 1. You should always start your recursive formulas like that. But instead of multiplying by 5, we were subtracting 4, so I'm just going to minus 4 on the outside. And that's all the problem asks for.